We're going to talk about congruence and the need to prove congruence, and this is something that I find a little bit tricky as we go through. It's important that we understand our angle proofs and some of the key things we looked at last lesson. So for example, our x rule, our f rule, understanding the sum of the degrees in a triangle is. How many degrees are in a triangle? 180. Those are the things rely or come in very heavily here. But to prove congruence, we need to make sure that we know that there are 4 ways we can prove congruence. We can have all 3 sides, and this is for a triangle. All 3 sides are the same. If all 3 sides are the same in both shapes, then they're the same size of the same shape. We can have 2 angles that are separated by an angle. Sorry, 2 sides that are separated by an angle. Now the angle, you'll notice that I didn't write, for tense sake, I'm going to write it this way. SSA. We can't have that. I can't write it that way. I can't have it prove like that because the angle needs to be between the 2 known sides. Does that make sense? Yeah. I'll explain why a little bit later on, but I just want to get the idea that that is not okay. We must have SAS. The angle must be between. With our third proof of congruence, it doesn't matter whether we have angle, angle, side or angle, side, angle. Why does it not matter? Because really, what I should be writing is that. Why does it not matter whether I write 2 A's or 3 A's? If I know 2 angles in a triangle, how many do I actually know? 3. Why do I know 3? They equal 180. So if I know 2 of them, I already know the third. So all I need is one side to be the same, and I know that my triangle is congruent. Does that make sense? And the last one only applies for right angle triangles, and that is if I have a right angle, a hypotenuse, and any other side. In reality, if we have 2 sides, any 2 sides of a right angle triangle that are the same, providing they're not, one's the hypotenuse and one's not the hypotenuse, provided we understand that we can get away with it because we can use Pythagoras to find our hypotenuse and go from there. Sweet? That's a lot of talking. What we need to do is do some practice. So I've got 4 triangles on the board. All of these are congruent. I'm going to give you a hint, they're all congruent, but it's about using our proofs and how we can show the working for that. So I'm going to do the working up in the top right hand corner here. So for triangle ABC, I'm trying to prove that they are the same. What do you think that means? What length? What AB? What does it mean?
5 centimeters.
The length AB, 5 centimeters, equals the length. Fill in the letters. What do you think I need to write there?
Equals A.
DE.
DE. Very good. So write that in our books.
Do I need see that one there? A, B, C, and F, G. Is that not question 4?
This is for question 1.
Yes, is that question 4?
That is question 4. Yep.
Is that like a part?
Yep.
Yeah.
No, that's 4. Thank you. Thank you, Nick. Very good. So, for question 1, Mikey, give me another side. What should I write here?
BC.
So he says side BC equals FE. You think, or are you sure? Yeah. Only criticism is it should be EF because B corresponds with. So the side B here is the same as our side E here. Oh, did I? Oh well. And the last bit of working goes what? Thank you, Jed.
C, A, and F, and D.
He's got his sides right. So, what have I established with those 3 lines of working? So I write triangle A, B, C. Oh, that's not a C.
Why do you have AD?
Yeah, so you marked it up.
Yeah.
So why do you have AD?
You get AD as A.
So just checking you're awake, boys.
And
Because C corresponds, because that's what he said. He said CA corresponds.
But he said
Can you
A.
He said AC, I'd go D.
Yeah,
Yeah.
that makes sense.
So I want to show that these are congruent. I could write is congruent with triangle DEF, but that's long. Don't want to do that. So rather than doing that, us mathematicians have a shortcut.
Just the middle one.
In brackets,